Okay, Year 12, I'm going to continue on with some of these questions from exercise 7.7. I'm going to pick up here with question 8b. Well, we've got to find the second derivative because it's quite a hard one. So 8b, what do we got? Let's take y equals ln tan to the minus 1x. Well, to find the derivative, we're finding the derivative of the log. It's the derivative of the function over the function itself. So the derivative of inverse tan x is 1 on 1 plus x squared over the function itself, which is inverse tan x. Well, let's write that all as one thing, and that's y dash. So we've got 1 on 1 plus x squared multiplied by the reciprocal, 1 on tan to the minus 1x, which gives us 1 plus x squared times tan to the minus 1x. Now you're probably thinking to yourself, why did I write it like that? Well, I wrote it like that because I have to differentiate it again, and it's easier for me to use the fat finger rule here rather than do a quotient rule with those two things underneath. So my second derivative, because I'm going to use the fat finger rule, I'll put my fat finger over what's inside the brackets, and I'm going to go minus 1 times all that, 1 plus x squared, in brackets, tan to the minus 1 x, and I take 1 away from the power. And then I multiply by what's inside the brackets, or what's inside, the derivative of what's inside the brackets. Now the derivative of what's inside the brackets, and by the way, there's another one there, it's a product rule. So it's the first, so 1 plus x squared times the derivative of the second, 1 plus 1 on 1 plus x squared, and I'm going to put this in the big brackets because it's a derivative of everything, plus the second, well, that's tan to the minus 1x, times the derivative of 1 plus x squared, that's 2x. Okay, well, let's tidy this up some. So I get minus 1 all over 1 plus x squared, in brackets, tan to the minus 1x all squared. And then I get multiplied by, well, this is really cool because that's going to cancel with that. And what do I get here? I get 1 plus tan to the minus 1x times 2x. Now if I just tidy that up, minus 1 times 1 plus 2x tan to the minus 1x over 1 plus x squared tan to the minus 1x all squared. And then I'm just going to multiply that negative through, and I'm going to go across, which I shouldn't do, but there's no space underneath. Negative 1 minus 2x inverse tan, or arc tan x, all over 1 plus x squared inverse tan x, all squared, which is the answer for the second derivative. So that was a bit complicated, but nothing that really is beyond you. I'm going to let you have a go at 8a. I want to look now at question 9. Now this is a particularly difficult curve to draw because we don't normally restrict the domain. Because we're not restricting the first domain, we get a repeating function here. So let's have a look at what happens. So we've got y inverse cos x. So y inverse cos, inverse cos sin x. So here we go. So here's 9b. 9. I've got y equals inverse cos of sin x. Now I could do sine is a cos of its complement. Yeah? So let's try that, because that's going to be an easy one. So I go cos to the minus 1, and that's cos pi on 2 minus x. And that gives me y equals, well, this will undo this. So I'll be left with pi on 2 minus x. Now, if I differentiate that, I'm going to get minus 1. And you think to yourself, sweet, I'm done. But I know that's not the answer. So let's have a look at this from another perspective. And this is a really difficult question. I don't think they're going to throw anything at you. Let's do it the norm another way. Y equals cos to the minus 1 sin x. And I'm going to let u equal sin x. Now, there's no restrictions on sin x. There's no restrictions on this u. And du dx equals cos x. And dy du equals, because this is now y equals cos to the minus 1 u, dy du is minus 1 over square root of 1 minus x squared. Sine squared. Yeah, 1 minus x squared, yeah. Now, we wanted dy dx. And that equals dy du minus 1. And by the way, that should have been a u on x. Square root of 1 minus. Now, I'll put the u back in, I get sine squared x. And here, I've got du dx, well, that's cos x. And here, I'm going to get minus 1. Well, 1 minus sine squared x is cos squared x times cos x. Now, here is where you have the trick. And this is really hard to see. Because I'm taking the square root, I can get a plus or minus answer. Because I'm taking the square root, I can get a plus or minus answer. So here, I get minus 1, and I'm going to call that the absolute value of cos x, because when I square root it, I get plus or minus, and I've got cos x. So now, what options have I got? Well, I'm going to get, if it's negative on the bottom, I'm going to get minus 1 on minus cos x times cos x. The negatives are going to cancel. And the cos x is going to cancel, and I'm just going to get 1. If I take the positive of inside there, I'll get minus 1 on positive cos x times cos x. And again, the cos x will cancel. But this time I'll be left with minus 1. Well, how do I know for what part? And this is where it gets tricky. So, for the absolute value of cos x to equal negative cos x. Well, where does that occur? And here's my cos curve. And I can see that this will be negative from these points, from pi on 2 to negative pi on 2, and from pi on 2 to pi. That's where that is true. So in that domain, so for x greater than or less than negative pi and greater than or less than negative pi on 2, because 0 is the same, as well as pi on 2 to pi. That's when we'll get a gradient of 1. Now, for absolute value of cos x equaling cos x, well, that's from there to there. Yeah? From minus pi on 2 to pi on 2. So this will happen in those parts. And outside that, we get the positive 1. Now that's going to restrict our domain. Remember, that's the derivative. That's going to restrict our domain of this function. Now, if the gradient is 1 or minus 1, that means that the function must be a straight line. So let's draw the function. Let's look at the function. Okay. From x pi on 2, negative pi on 2, we've got a gradient of negative 1. There it is. Gradient of negative 1. And when x is 0, well, I've got to do cos of cos. Well, sine of 0 is 1, and inverse cos of 0, sine of 0 is 0, sorry. Inverse cos of 0 is 1. So it's going through. Let's double check that. I think it's going to be pi on 2. So here I go. So what have I got to do? When x is 0. So clear that. I've got to go, was it inverse cos? So shift cos sine 0. and maybe that'll work. I get 90. So that is pi on 2. Oh, let's rub that out and write that in black. Sorry, pi on 2. And we know that between there and there, it's got a gradient of 1. So this thing is coming down like that. And then at that point, those 2 points, the gradient then changes. It has a gradient of -1. So it's going to start going like that. And this one's going to go like that. What's this maximum value here? I wonder. What's that maximum value? That, well, we'll go quickly to Desmos. I thought I had Desmos up. And we'll graph this. And we're graphing y equals inverse cos of sine x. And there you can see it. And there's my pi on 2, and I'm pretty sure that that'll be pi up there. We go there, look at that, pi, and that's minus pi on 2, and then it changes. And you can see it goes on forever. So if we go back here, we know that that is pi. And that's what it looks like. So in the answers, where they state these regions, that's what it's doing. Because when you square root that cos squared x, you get a plus or minus. So you need to, that's a really difficult question. And I think it's beyond the scope of what we do. So that's question 9. I'm going to let you have a go at question 10 on your own. Find the derivative of that and draw the graph. What you'll find is that the derivative is 0 for x, but you're going to find a different constant of the original equation. So when x equals 0, and you're going to get different answers. I wouldn't waste too much time on it. What I'd rather you do is ones from question 11. So I'm going to have a go at some of the ones from question 11. So I'll try 11a and 11e and then let you get on to them. So 11a. And what do we got? Y equals inverse cos e to the 2x. Y equals inverse cos e to the 2x. Well, again, let u equal e to the 2x. Therefore, du dx equals 2e to the 2x. Y now equals inverse cos of u. So y dash will equal minus 1 on the square root of 1 minus u squared equals minus 1 on square root of 1 minus, well, e to the 2x squared will be e to the 4x. And that's dy du, sorry. But what we want is dy dx. So dy dx equals dy du minus 1 on the square root of 1 minus e to the 4x times du dx, which is 2e to the 2x, and then I'll just tidy that up, minus 2e to the 2x over the square root of 1 minus e to the 4x. So that's not too hard, and they're the ones that I want you to practice. Let's have a look at e. and E is e to the inverse tan x. So here's 11e, y equals e to the inverse tan x. And again, you want to do these using substitution. So we're going to let u equal tan to the minus 1x. Therefore, du dx equals 1 on 1 plus x squared. And then you go, righto, y equals e to the u, dy du equals e to the u, which is e to the inverse tan x, but we want dy dx, which is dy du, so e to the inverse tan x times 1 du dx, 1 on 1 plus x squared, which equals e to the inverse tan x over 1 plus x squared. And that's it. And they're the sort of questions I want you to be doing. I want you to make sure you can do 11. So have a go at those tonight. Don't worry too much about 9. 9 is pretty difficult. And question 7, which I did in an earlier YouTube clip, was also pretty hard. Okay, good luck.